Have you ever noticed like, how incredibly easy it is to focus on what's disappearing in the world?
Oh, definitely. Yeah.
Like, we always hear about what's going away, but we so rarely notice the things that are, well, quietly fighting their way back.
Right, because loss is loud. It's immediate.
Exactly. And speaking of fighting back, picture this. For exactly 100 years, the camera traps in California's Sequoia National Park caught basically nothing but ghosts.
Ghosts and what, a whole bunch of raccoons? Probably.
Pretty much. Just raccoons and empty woods. For a whole century, there was zero sign of the apex predator that used to roam those mountains. Until last week.
Which is just incredible.
Right. A lone wolf, an animal that's been functionally extinct in that specific area since the 1920s, just wandered right into the frame.
Yeah, and the crazy part is nobody put him there.
Exactly. No wildlife agency tranquilized him and drove him up a mountain. He just, remembered the way.
Yeah, it really is a staggering piece of
Yeah.
news because, like you said, we're so conditioned to notice the subtraction.
Yeah.
A habitat vanishes or a species slips into extinction, and it's this huge sudden thing. But recovery is often really slow, it's silent, and it's incredibly easy to miss if you aren't looking for the right mechanisms.
Okay, let's unpack this. Because that lone wolf in Sequoia is really just the beginning.
Oh, absolutely.
We have a really fascinating stack of sources in front of us today from BrightNews Daily. And this is dated today, May 21st, 2026.
It's a great collection of articles.
It really is.
Yeah.
And the overarching theme of these stories is what they're calling the stubbornness of life, stories of remarkable recovery. So we're basically going on a global tour of comebacks in this deep dive.
And it's a brilliant collection to analyze because together all these sources answer a really profound question.
Which is?
When something truly disappears, whether that's a species or a fragmented habitat or even a community's hope, what does it actually take to come back?
Right.
And the answers are surprising. It goes way beyond just, letting nature heal. Sometimes it requires these invisible biological maps.
And other times, according to these sources, it literally involves pulling a high-definition DNA profile from a pile of animal poop.
Yes. We are definitely going to get into the science of tracking scat later on.
Oh, I can't wait. But to really understand recovery, we first have to look at unguided, natural comebacks.
The ones that happen totally on their own.
Yeah, where life relies on these invisible pathways that somehow outlast human memory. Which brings us right back to our Sequoia wolf.
Right. To appreciate the scale of this, you really have to look at the historical data. 0 confirmed sightings in 100 years.
100 years. That's a long time.
It's massive.
Yeah.
Wolves were completely extirpated from California's Sierra Nevada. And when biologists use that word extirpated, they don't mean extinct globally.
Right. It means locally wiped out.
Exactly. Violently, locally eradicated. But this new wolf, biologists believe it likely traveled south from recovering populations in Northern California, traversing hundreds of miles of terrain on its own.
See, reading through that report, it made me think of, okay, imagine finding a fully functioning vintage flip phone hidden in the walls of a brand new smart home.
Oh, I like that analogy.
Like, it belongs to a totally different era. The modern subdivisions aren't programmed into it, but it still works. The wolf is running on that old software.
Yes, exactly.
It's following this invisible geographical memory to find a habitat that was emptied out a century ago.
That is a phenomenal way to visualize dispersal behavior. Because animals, they don't just wander aimlessly.
They have routes.
Right. They follow topographical funnels, things like river valleys, ridge lines, ancient scent corridors.
Even with all the human development in the way.
Even with that, the landscape still holds the structural space for this predator. The ancient highway was always there, just, waiting for a traveler.
Man, and speaking of ancient highways, if we shift from the mountains of California out to the open ocean, we see something incredibly similar.
The humpback whales.
Yes. So BrightNews Daily also reported on these 2 humpback whales that were just documented, completing a 15,000-kilometer migration between Australian breeding grounds.
Which officially makes it the longest humpback migration ever recorded by human observers.
Wait, hold on. Recorded by human observers is the key phrase there, right? Because I was reading this and wondering, did these whales just invent this 15,000-kilometer route out of nowhere?
Like a brand new oceanic shortcut.
Yeah. Or were we humans just completely blind to it this whole time?
What's fascinating here is we were completely blind to it.
Oh.
And the mechanism of how we finally saw it is this huge marvel of modern data collection.
Oh.
Scientists identified these specific whales using fluke photo ID matching.
So matching their tails.
Exactly. A whale's tail fluke has these serrated edges and distinct scarring from, barnacles or orca attacks. It acts as a unique oceanic fingerprint.
Right.
So by feeding thousands of photos taken by researchers and citizen scientists into an AI database, they matched the exact same whales at completely opposite ends of the globe.
So they definitely didn't just invent the route.
Not at all. The route was always there. But the reason we're only seeing it in 2026 comes down to historical numbers.
Right, because of the whaling era.
Yes.
Ah.
During the 20th century, humpback populations crashed by over 90%. And when you remove 90% of a population, you don't just lose the physical bodies.
You lose the culture.
Exactly. You lose the network. You lose the behavioral data that older whales pass down to younger whales.
Oh, wow. So the route went dark.
It went totally dark. There simply weren't enough whales swimming it to reveal the pattern to us.
So population recovery isn't just about saving the biological animal. As their numbers swell, the biological infrastructure of the ocean itself is lighting back up.
It reilluminates ancient highways we didn't even know existed.
The map was never lost to the whales. It was only lost to us. And, it makes you wonder about the invisible pathways in your own life or your career or your industry.
Oh, absolutely.
Like how many routes or opportunities are sitting there totally dormant, completely invisible, and they just need the right conditions to become visible again.
That framing actually leads perfectly into the next core concept from the sources.
Okay, let's hear it.
Because if nature remembers the way back so effectively, if wolves and whales have these invisible maps, why doesn't everything just recover on its own?
Well, because the open ocean is one thing. But on land, an animal trying to follow an ancient map usually hits a literal concrete highway.
Precisely. We've fractured the landscape. So recovery isn't always about complex, high-tech engineering. Sometimes it's simply about removing the roadblocks.
Right, and the stack details these massive rewilding initiatives happening across Europe right now.
Yes, the European projects.
And what stuck out to me is that they aren't trying to build these massive new megaparks. They know that's politically and economically impossible in dense areas.
Right, you can't just clear out half a country.
Exactly. So instead, they're just trying to link up the fragmented patches of natural habitat that already exist.
If we connect this to the bigger picture, the biological rule they're operating under is incredibly simple. Connection is survival.
Connection is survival.
Right. When an isolated population, say, a local group of lynx gets trapped behind highways and urban sprawl, they suffer from genetic bottlenecking.
Because they can't reach any other lynx.
Exactly. They interbreed. Harmful mutations start building up in their DNA. Their immune systems weaken, and eventually, a single localized disease can wipe out the entire group.
It's like trying to run a thriving local economy when every single town's roads are blocked off by concrete barricades.
That's a perfect way to look at it.
Right. Like town A makes bread, town B makes shoes, but nobody can trade. And without trade, the entire system just collapses.
Yeah.
In biology, that trade is genetic exchange.
Exactly.
Yeah.
You don't necessarily need a brand new continent. You just need to open up a trade route so the genes can flow.
So the goal of rewilding Europe is just functional.
Purely functional. Build a wildlife overpass over a highway or restore a riverbank, and you allow nature to flush the local gene pool.
You just remove the barricade.
Yes. But you don't even need an entire continent to prove this point.
No, you don't. And here's where it gets really interesting. Our source includes a hyper-local example from England, the Kentish Milkwort.
Ah, yes. The tiny wildflower.
It's this incredibly rare flower found on England's chalk cliffs. And according to the report, since 2013, the population of this plant has increased 7-fold.
7 times. That's a 700% increase.
Which is massive.
It's massive. And it's fascinating because we usually assume a comeback of that magnitude requires, intense human intervention.
Right, like teams of botanists in lab coats.
Exactly. Cultivating seedlings in greenhouses, adjusting the soil pH drop by drop.
A botanical ICU.
But the intervention here was shockingly minimal. Conservationists didn't replant a single milkwort.
Wait, really?
Not one. What they did was implement targeted grazing management.
Wait. Their solution to saving a super rare, delicate flower was to bring in heavy animals to trample and eat the area.
I know it sounds totally counterintuitive, but let's look at the mechanism.
Okay.
The chalk cliffs have naturally thin soil. Historically, that harshness kept fast-growing, aggressive grasses at bay, which allowed the low-lying milkwort to get sunlight.
Okay, that makes sense.
But because of modern nitrogen pollution drifting over from nearby agriculture, the soil got artificially enriched.
Oh, I see.
So suddenly, these thick, tall grasses exploded in growth, completely shading out the milkwort.
Ah. So the barrier wasn't a lack of seeds, it was literally a roof of grass blocking the sun.
Exactly. So conservationists brought in cattle or sheep for short, highly controlled bursts.
Like natural lawnmowers.
Right. They graze the aggressive tall grass down to the nub. And because the milkwort grows so incredibly close to the ground, the grazing animals pass right over it.
Wow. So the heavy machinery clears the canopy and suddenly the milkwort is flooded with sunlight.
The plant did the rest. It was there in the soil the whole time, waiting for the pressure to ease.
That is amazing. Okay, so we've established that nature needs space, it needs genetic trade, and it needs that release of pressure to recover.
Correct.
But what happens when a surviving population is so unbelievably small and fragile that human interaction itself becomes the barrier?
That is the big question.
Like, how do you monitor something you can't even touch?
And this brings up the central paradox of modern conservation. Sometimes the sheer act of studying a fragile animal stresses it out enough to threaten its survival.
Right. Which brings us to Gilbert's Potoroo.
The world's rarest marsupial.
It's this small, nocturnal Australian animal. Picture a tiny kangaroo, roughly the size of a rabbit, darting through this incredibly dense, unapproachable brush.
An animal truly living on a knife's edge.
Now, the source notes that scientists are saving this animal using DNA extracted from its droppings. Scat.
Yes.
I gotta ask, is tracking a pile of poop really a robust enough strategy to save a species from the brink? It sounds, frankly, kind of desperate.
I mean, it sounds like a last resort, but scientifically, it's actually a cutting-edge strategy. It's called non-invasive genetic monitoring.
Okay, break that down for me.
Sure. So, when any animal digests food and passes scat, the friction of that process sheds epithelial cells from the lining of its own intestines.
Wait, so the poop is literally coated in the animal's own cellular material?
Exactly. It's full of DNA. So conservationists hike into the brush, collect these droppings, and take them back to the lab.
And they can actually read it?
Yes. They isolate those epithelial cells and extract the DNA using a process called PCR polymerase chain reaction. They amplify the genetic material until they have a highly readable sequence.
Wow.
From a single dropping, they can determine the individual identity of the Potoroo, its sex, its exact diet, and its kinship ties to other Potoroos in the area.
So they can map the entire family tree of a forest they can barely even walk through?
Yes, with zero capture required.
But why go through all that trouble in the lab? I mean, why not just set out some humane traps, tag them, and take a quick blood sample like they do with bears or wolves?
Because small mammals, like the Potoroo, are incredibly susceptible to something called capture myopathy.
What is that?
The sheer panic of being confined in a trap, even a safe one, causes severe stress that can lead to muscle necrosis or even death.
Oh, wow. So you literally might kill it by trying to save it.
Exactly. Plus, trapping disrupts their breeding and makes them vulnerable to predators. By relying on scat, scientists can guide breeding decisions and monitor genetic diversity without ever laying a hand on them.
They get a crystal clear picture using only the traces it leaves behind.
There is a really profound takeaway for you, the listener, in this methodology.
Yeah.
So often, whether in business or research or life, when we want to fix a struggling system, our instinct is to aggressively intervene.
We want to trap the subject and put it under a microscope.
Right. But sometimes the most valuable data you can possibly gather comes from the quietest, most unglamorous traces. You just step back and refuse to disrupt the system you're trying to save.
I love that. Look at the traces instead of forcing the intervention.
Exactly.
Now, as we move into the final section of our deep dive today, we have to recognize a bit of a shift here.
Right.
Because this stubbornness of life surviving by finding invisible paths or waiting patiently for the heavy grass to be cleared away, it isn't just a biological phenomenon limited to wolves and wildflowers.
No, it's deeply fundamentally human. Biological stubbornness and human psychological resilience share a lot of the same architecture.
And the final story in today's stack perfectly illustrates this. It's about a Ukrainian soccer club, FC Chernihiv, who advanced to the 2026 National Cup final against all odds.
It's an incredible story.
Now, just to be totally clear here, as a context note for our listeners, we are impartially reporting the facts exactly as they're outlined in the BrightNews Daily source.
Right.
We're focusing purely on the themes of resilience highlighted in the article. But the facts, as reported, are really striking.
Very striking. Chernihiv is a frontline city.
Yeah.
And this soccer club has played through immense displacement, deep physical uncertainty, and severe material hardship over the last few years.
And against those odds, they made it to the Cup final. Honestly, reading the details of their season, I immediately thought of the Kentish Milkwort.
Oh, the flower on the cliffs.
Yeah. This team's journey is like that tiny wildflower pushing its way up through the dense, crushing chalk. Except, they're wearing cleats.
I mean, the comparison really holds. It's that same irrepressible push upward against a hostile environment.
All right.
But we really need to zero in on the psychological mechanism at play here. The source explicitly notes that this cup run isn't just viewed as an escapist distraction from the war.
Right. It's not just a way to kill 2 hours and forget reality.
No, it's a statement. It's a symbol insisting that normal life, human ambition, and competition still exist.
Yeah.
And that they still matter.
Survival isn't always passive.
Exactly. We've talked a lot today about nature waiting passively for the pressure to ease. But in the human realm, you can't always just wait for the tall grass to be cleared away by someone else.
Sometimes survival requires an active, conscious refusal to disappear.
You have to lace up your boots and play the game while the crushing pressure is still actively there.
Wow. So what does this all mean? We've gone from the Sierra Nevada mountains to the ocean depths to a chalk cliff in England, the Australian bush, and a soccer pitch in Ukraine.
It's been quite a journey.
It has. And looking at today's stack of sources, the through line is remarkably clear. A comeback doesn't always require a cinematic miracle.
No, it doesn't.
It requires time, genetic or social connection, and an absolute stubbornness to exist.
And that is really the core insight to pull from this analysis. The next time you face a massive setback or you look at a system that seems entirely broken, don't immediately assume you have to tear down and rebuild it from scratch.
Right.
Ask yourself, where are the ancient highways here? Or what is the subtle, simple pressure that just needs to be grazed away so natural resilience can take over?
The capacity for recovery is probably already there.
It's built into the DNA of the system, just waiting for a little room to breathe.
Which leaves a final question to mull over today. Think about the things in your own life that you might have written off.
Yeah.
What if the very things you think are gone forever? Whether that's a creative spark, a severed relationship, or a sense of community. What if they aren't actually extinct? What if they're just dormant, waiting for you to remove the one tiny barrier blocking their return?